This week, we're going to answer a user's question on GitHub about how they can change the aesthetics of the Skew-T diagram. Welcome to another MetPy Monday. Hello, my name is John Lehman, a software engineer for NSF Unidata. This week, I wanted to look at this issue that was filed on the MetPy GitHub of how can we change the aesthetics of the Skew-T diagram. Specifically, this user wants it to look more like a Skew-T diagram from NCL, and they gave us an example here. While we're not going to work on changing the shape of the plot, that would be pretty involved, though possible. After all, it is Matplotlib's motto, making the easy things easy and the hard things possible. We're going to focus on some of the other aesthetics, like this green banding. We're going to change the styling of the plot to look a little bit more like this, and I'm going to add this super and subtitle up here as well. So let's go over to a notebook and get started. First, we need to get our data. So we know that's going to mean importing datetime. So from datetime, I'm going to import datetime from Siphon .simplewebservice.wyoming. I'm going to import Wyoming upper air. And from metpy.units, I'm going to import the units registry and the pandas data frame to unit arrays helper. We're going to go ahead and get our sounding. In this case, of course, we're going to go with OUN. Central Oklahoma always providing interesting soundings. And we're going to go with the May 31st, 2013 outbreak 12Z sounding. Going to use our Wyoming upper air request data method. And remember, you can always use Shift-Tab and see that we're looking for time and site ID. So in this case, date and station. Now we've gone over how to get data from our various upper air data sources and other videos. So if some of this is unfamiliar to you, I suggest you go check those videos out. I'm going to go ahead and attach units. And we get our warning, but that's okay. And now let's get ready to make a plot. So I'm going to import matplotlib.pyplot as PLT, and from metpy.plots, I'm going to import the Skew-T object. So our stock Skew-T, if you will, from a MetPy example, I'm going to create a figure, create an instance of the Skew-T object, and I'm going to pass it fig. Oh, we should have a capital S there. And our rotation, we'll set it to 45. Skew.plot, data pressure, data temperature. And we'll make that a nice tab red. Skew.plot, and we'll actually just paste most of that line, go back in here and change temperature to dew point. Tab green. Okay, skew.plot barbs to put our wind barbs on. And we're going to look at pressure, U wind, and V wind. And we'll go ahead and put our fiducial lines on there, dry adiabats, mixing lines, and moist adiabats. And let's see what we get. Okay, so that's not too bad. I'm going to go ahead and reduce our winds by, well, let's decimate by a factor of 2 and see how that looks, just to make that axis a little cleaner there. That's not too bad. Okay, so there's our basic default Skew-T. Now, I'll agree that you might want to change some line weights or something to make this look a little different, but in this case, we want to make the plot look a lot different, actually. We want to make it look more like this from NCL. And there's quite a few differences here. You notice that the fiducials have different line weights and different colors. We're plotting temperature in black and dew point in blue. We've got our parcel path as a dashed red line here. So we've got quite a bit of different things going on, not to mention all of the information contained up here in the header. So let's go ahead and see what we can do. I'm going to copy my original figure here, and let's go back and start changing things. Okay, so the first thing that I can change is the color to black and blue for our data. The winds are fine. Let's look at the dry adiabats. So I'm going to make a line width of 0.5, a line style of a solid line, and the colors of the lines I will set to tan. I'm going to go ahead and paste that into mixing lines and moist adiabats. And for mixing lines, I'm actually just going to change the line width. I'll leave everything else the same. For moist adiabats, we'll do line width, line style, and colors are actually going to be green to match more closely what's on NCL. Okay, so that's a little bit closer to what we're looking for already. Let's see what else we can do. We know we need to add the banding of colors. So let's try that next. And we're going to use the fill between method. So I'm going to say for I in range. I'm going to go from minus 150 to 40 Celsius just to make sure I cover everything on the plot in steps of 10. And because I only want to color every other interval, I'm then going to skip every other there. On Skew, we can actually call .ax, which gives us the axes object. And then on it, I can call fill between x, which is just a regular old matplotlib method. And I'm going to call skew.ax.getYlim, because we have to specify the y values. And this way, no matter what the user sets the plot limits to, we'll get those. And then I and I plus 10 will give me that from x to x plus 10 range. And for color, I'm going to specify pale green. Okay, so now we've got something that's really starting to look like the NCL plot. We've got those alternating bands of color. Our line colors on the plot are getting more similar. So we're getting somewhere here. Next, we need to add a parcel path and then put some information up here in the title of the image. And for that, we're going to need to calculate some derived parameters. So I'm going to put a cell above here. And I'm going to import metpy.calc as mpcalc. Now, what we had in the example from NCL were the pressure and temperature of the LCL, the precipitable water value, and CAPE. So that's what I'm going to put in here. Luckily, MetPy has methods to calculate all of these. So the LCL pressure, LCL temperature come from mpcalc.lcl. And if you're not familiar with what that takes, you can always look at the documentation. But it's going to take the starting pressure. It's going to take the starting temperature. And it's going to take the starting dew point. All right, so that worked. Now let's go ahead and see what else we can calculate. I'm going to just copy that. We'll change it as we need it. Save ourselves some typing. Okay, so precipitable water. mpcalc.precipitable water. And that's going to take pressure and dew point, but it's going to take the profiles. So I want to pass it everything there. the parcel profile, mpcalc.parcel profile, and that's going to take all of the pressures at which we want data, but then it just needs the starting temperature and dew point because it is calculating the profile after all. And we'll go ahead and calculate CAPE and SIN using the CAPE-SIN method. It's going to take pressure, temperature, dew point, and parcel profile. So pressure, temperature, dew point, and parcel profile. Okay, now we have a message about some duplicate pressures, but that's okay. We've got all of our calculated parameters now. So now what we need to do is add those as a plot title. So plot.title, I'm going to use an F string and put it in bad quotes here because we'll have single quotes inside. The first thing in the NCL was the station name, which we have in our data as station, and we only need one instance of it. We have station number. Again, we only need one instance of it. We'll put that in curly braces. If you need a refresher on F strings, we have several videos on how they work. Okay, so now we've got our station, station number. Actually, that's going to be our main title, so let's see how that looks. Yeah, I like that. So I'm actually going to call that the super title. And then below it, we'll put a title. And it's going to be another F string. And it's going to have all of our metadata, like pressure LCL is going to be equal to LCL pressure. And we want no places after the decimal. We want to go ahead and drop the unit. That's how it was in the plot that was shown. And let's make the font size a little bit smaller so we can fit everything and make the color brown. Okay, that looks a little bit better. Let's go ahead and add the date and time up here. So that's our date that we got the data from, and then we can format that right in the F string, year, month, day, hour. Okay, that looks right. Now we'll keep adding in down here in our metadata. We've got the pressure of our LCL, temperature of the LCL. It's going to be the exact same way. It's LCL, not pressure again, but temperature. 0.0 F, and let's do magnitude on that as well. And actually it looks like in the NCL they had C in brackets there to indicate the unit. Great. Okay, next is precipitable water, which they label PWAT, and in centimeters. And I know that precipitable water comes back from our calculation in millimeters, but luckily we can use the wonders of unit awareness to go ahead and say we want to go 2 centimeters and then take the magnitude of it. And we need a closing curly brace there. Okay, that looks good. I'm going to line wrap just to keep from going off the edge of our screen here. And let's add CAPE. And I would be curious why they don't capitalize CAPE. If anybody knows, I'd be very interested to hear in the comments. All right, and we have our CAPE value dot magnitude. Oh, and we need our double quote there. Okay, now we're actually very close to where we want to be. I'm going to go ahead and modify the font size up here. Let's say to 14. And the last thing that I really see that's a big difference is the axis label. So I'm going to get to the axis object again and then call set Y label. And they label it as pressure, hectopascal. Set X label, temperature, and Celsius. All right, so there we go. We have something that looks a lot more like an NCL plot. Actually, we can do one more thing. We already have our partial profile calculated. So let's plot it. We've got our partial profile, and it was red, and the line style was dashed. Yeah, so okay, now even more like our NCL plot. So as you can see, with just a few lines of code and about 10 minutes, you can use the power of Python and the fact that all of the plots are built on matplotlib, and we give you access to all those underlying objects, where you can just use your standard matplotlib calls and modify it to look like really pretty much anything you want. I hope that you found this useful, and I'll see you on next week's MetPy Monday.